Hello and welcome to SolidCAM 2021 Q4 Virtual Summit. My name is Michael Vinetsky, Vice President of Product Management. Today I am glad to share with you our last upgrade in SolidCAM 2021 SP3, the new multi-channel simulation. I hope this presentation will show you the power of it and all of you will enjoy this new amazing functionality. Let's get started. When we're talking about channel synchronization, we always meaning very complex machines with multiple tables and tasks. But you can easily get for benefit for even classic 3-axis machine by organizing your setup, operation execution order, and precise collision detection for all machine elements. Let's switch to the software. In following example, I want to show you simple prismatic 3-axis part, but machines on 3-axis machine. Let's see the machine. This machine is HAS VF2, really simple one, classic, very powerful, and we are using 2 vices for this part. You can see it in setup. And vice number 1 is hold the part for initial state, and vice number 2 hold the part for the second operation. So once you click here on the vice 2, you can see also the second part. It's in transparent mode, so you can see this is the initial one and second operation. Here is the setup. I am going to change it a little, just drag it 100 mm in X direction, make it a little bit closer. So what I see here is order of operations, and let's try to analyze it. I'm not going to open each operation and show what's going inside, but let's analyze the order of operations. So we have a first site was machined with Mach 1 position 1. Okay. After it we have a part transfer machine control operation, machine the second site, and last machine control operation, and it's very important for us, it's called release stock. I'd like to name it RST. So I can go to the setup, right click on it, channel synchronization, and see what we have here. I will cancel all changes in the tree by pressing the X here, okay, and 1, 2, 3 order. So what I see here is the setup, part transfer, and release stock, same as we see in the country. To understand how to edit it, I can switch to table color view, and now I see it's in different colors. The green color is the first site, and the blue color is the second vice working. Now I can go after the part transfer, right click on it, and add a new workpiece. Once I edit it, all operations jumps to the start of the execution order. Now I can drag my setup to the start, drag the release stock to the end, and now I can edit the order. So first one, what I want to edit, I want to analyze by the tool numbers if I can save any kind of tool change time. So let's see, I have a T8 running here, and same tool is used in this side. I can just drag with T8 to the second one. Where is it? Yep. And now you see this tool will not change on the machine because the same tool is used in both operations. Same I can do with the T7, T6, and T4. I can drag even number of tools by single dragging, okay, and T1 is already together, okay. So what I see here is 1, 2, 3, 4, and 5 tool changes was skipped because it's not necessary anymore for this kind of order. So I didn't change the operation technology, tool path, or cutting conditions, but I still get 35 seconds of saving time only by reordering the operations without changes any technology. So how I can see now in simulation what will happen on the machine. So I will save it, and now you see here the toolbar we have a new icon what's called SolidCAM simulator. If you run it from the channel synchronization, it will always run in multi-channel mode. If I press on it, what I will see is two separate windows what show us what will happen on the machine. Let's rotate it a little. Okay, and see how it looks like. So first, you see the initial workpiece and you see the machined workpiece for the second side. In both windows, you can run the simulation and stop it, depend on which window your mouse is it. Okay, if I run it, you will see the T1 is face mid running on the first workpiece, and once it's finished, it's going to the second workpiece. Once we will reach the T number 4 here, you will see the operation execution will be back to the first workpiece. So it helps us to understand what will happen on machine and what's the real execution order for this part. Here we see it's back to the second screen. I will stop it, okay, and run the machine simulation. Of course, machine simulation will show you the whole machine with all elements inside, and if you're running it from the channel synchronization, you will automatically highlight operations what is executed on the machine. So I'm going to move list and just drag my mouse there. You see operation number 36 is executed now with T1, so I can go and see it's in simulation. So let's run whole simulation and try to understand if we have any problem inside. So of course you see the tool is jumping from the workpiece to workpiece, and it's what we are designed. It saves the tool change time. We see now the first problem is recognized. I will stop here and try to understand what happens. Okay, have a small collision here. I think it's okay for me because it's a cooling pipe. It will not really happen on the machine. It's like a part of 3D model what can be removed. And let's continue forward. Okay, we have again same collision. Okay, the tool is continue to collide with us, and now we have additional collision, but it looks much more real than before. I will stop here and let's see what's happened. I'm working now with the right tool on the pocket on the first part, on the right device, and same time I have a collision with the tool with the left part. So how I can solve it? Let's stop the simulation and go back to the setup. You remember I moved my part 100 mm. Of course it was on purpose. So let's move it back, and you can verify it in machine preview and see if the distance looks good for you. I think, yep, it's good enough, and let's back to the simulation. I don't want to start channel synchronization now. I will directly go to simulate and machine simulation here. Okay. Only one difference: you will not see the real order of operation, but you still will see the highlighted operations in the country according to the part execution. So if I scroll to the first operation, you will see the operation face me on the second wise is highlighted. But let's go to the problematic one and try to see what we have now. It's calculate the updated stock. I can move it a little here. And what we see here, okay, there is no collision anymore, and the machine can cut this pocket without any problem. Okay. Let's back to the presentation. So how we've seen in this example, the channel synchronization can be used even in 3-axis single channel machine. So first, it's used to simulate the multi-site machining workflow. It helps you to detect collisions between all workpieces what you're going to machine on the CNC machine. It's helps you to optimize the machine process and reduce the machining time by skipping the tool changes. And of course, once you are using this kind of machine setup, you are reducing run-to-run cycle execution time, increasing it by adding more parts to the single setup. It's give to your machine more runtime and less idle time. Okay. So what we see here is the initial country can be optimized by simple drag and drop to avoid unnecessary tool changes. In this previous example, we saved 35 seconds only by this feature. Also, you can verify your execution order in 2 different environments. First one is machine simulation one. A machine simulation gives you the full simulation of what happens on your machine. You can see collision between all components, even with component not involved in current cutting process. And of course, you can use the multi-channel simulation, a new one, to emulate and simulate all process what's coming on your machine in all workpieces what involved in the process. Each workpiece will show in separate window. You will not see the collision between workpieces like in machine simulation, but you will see the real operation execution order. To run this simulation, you can go to the setup, SolidCAM simulator in channel synchronization mode, or run it from the channel synchronization toolbar. A second example of using one single channel synchronization is working with multi-table machine and single channel. Let's go to the example. In this example, I am going to use also Haas machine, but very interesting one. It's a new UMC Duo machine, or is what we are used to prepare this presentation. So first, before I start to describe what's done here, let's open the machine and see what's happened inside. I will skip the definition of VMID. I'm going directly to machine preview. What I see here, it's classic 5-axis table. We can find it on any UMC machine from Haas company. And in addition to it, we have a 2-axis, 3-axis table on side. And from my point of view, it's amazing idea. You can prepare your part to mount it on 5-axis table and make a final operation in one single cycle. So how we can use this machine in SolidCAM? So first, let's open setup. What you can see in the setup, I go directly to machine preview. It's first we see the machine, okay? Same what we see in machine preview in VMID. And here I also see the fixtures. So first I start to work from Mach 1 position 1 fixture, okay? It's marked by stock in here, okay? I'm moving to rotary table for the second operation to make all milling. But of course I cannot mill from downside because it's a fixture there. And once I finished here, I'm going back to the fixed table and finish my part. So just to complete all machining cycle. Okay. If I go to the channel synchronization, I can see the new execution order here. So in this order, we saved a lot of time only on T1. You can see it's in the country. The operation 1 use T1 is a face mill. Operation 2 use T1 on the rotary table. And the last setup also used T1 for finalize the part. So just by organizing this tool in the channel synchronization, I saved 14 seconds. And you can see here a lot of different places where we are saving tool changes. So let's see how it looks in new simulation channel mode. So how I said, we can start it from the toolbar in channel synchronization. It will always start it in the multi-channel mode. What I see here is the 3 different windows. It's not 2 windows like was in previous part. And in each window, I see different workpiece and different fixture. So we start from here, moving to the 5-axis table, and moving back to the initial table to finalize the part. Let's run the simulator. And what I see here is the T1 is just jumping from part to part, and you see the real execution order of operation. Okay, we can stop it. And now I will open the machine simulation, and we can verify if we have any kind of collisions between components. So once I opened it from channel synchronization, my channel synchronization still is opened. I can move it down and see what we have in the machine. The first part, initial stock, second operation, and the last finalizing operation on the same 3-axis table. Run the machine simulation. I will do it a little bit faster. Okay. And you see the tool jumps from workpiece to avoid unnecessary tool changes. Same time you see the operation what is executed now is highlighted on the channel synchronization. Okay, part is finished and prepared for the second part loading. I'll close the part. Let's back to the presentation. So how we seen in this example is not only collisions between two components mounted on single table can be detected. In this example, you understand, you've seen the collision even between components what not mounted on a single table can be detected as well. And we are not limited by the number of workpieces what we can simulate and emulate in our channel synchronization. Each workpiece will be opened in separate window. Of course, if you're going to see 6-7 workpieces or more, I really recommend to use second screen, and you can open it in second screen and see very well what is going on in your simulation. Okay, of course, when we are talking about channel synchronization, it's really hard to skip the turning machines. So, but in turning machines, people who use single channel machine like has ST series without lower turret or something, will really not know the power of channel synchronization, what it can give you. At first, reordering of operation can give you the same benefit as a milling machine, a little bit less because the tool change time is less than milling. It takes parts of seconds and not 7 seconds like a milling machine. But one of the biggest features what you can get in rotary turret machine is new simulation. I will back to the SolidCAM. Let's open part with rotary turret example. So the machine I am going to use now is the Haas DS30Y machine. It has 2 tables and 1 single turret, rotary turret, and this turret is generally have 12 stations, but additional stations also can be used. So let's open the machine. I'm going directly to the machine preview, and we see, I think everybody is really familiar with this kind of machines. Have a rotary turret, main spindle nose, and the back spindle nose. Close the machine preview. And now I want to go also to the toolkit, because in this machine the tool setup is very important. I'm going to open the machine preview and you will see how the machine setup looks like here. Okay, I'm going to zoom it on it and I will hide the machine just to see the tools there, and you see how many different holders and tools and tool assemblies are used there. You can find in any company who work with this kind of machines. The tool holders are really complex if you want to get maximum from your CNC machine. So how the new simulation can help you here? I will close it and run our regular simulation, solid verify, to see how this part will be done. Okay, we see a lot of tools are working on it, and in general there is no too much problems. Part looks good, and we didn't see any critical collisions there. But it's not a real situation. If I go to the, let's mute it. If I go to the new simulation, the picture will be different. once Paul wrote, okay, a lot of holders, take a while. We will see the simulation looks completely different. What's the difference we see here? First, I see wall. The tool assembly is mounted here. And now when I run the simulation, I see more clear picture of possible collisions between machine components and tools. And once we will reach to the internal turning operation, here, let's stop it here. We detect some collision, so let's go to this collision and try to see what we have here. Okay, here is it. I see the tool what is completely not involved in the process, but mounted on same station, even on same turret, is collide the material during internal turning. So this kind of collision can be verified in new simulator. Let's back to the presentation. So how we see we can not only detect collisions with tool and tool holder and material, you can also detect the collision with neighboring tool and the material or fixture. You can see the complete assembly to verify your setup. And of course, I will show it now in a part. You can use a turning mode for using powerful turning simulation. Let's back a little to the machine. And now I am going to the options what we have here. You can find a default, then solid verify style, 3D simulation, and turning style. When I switch to turning, we see very known for us simulation of 2D, and but the difference here, I see the tools in 3D, so you can more precisely recognize the collisions. Also here I see I have a possible collision. So let's back to the interface and try to see all the options what we have. So in the first one we have options like a fly out window. If I uncheck it, okay, I will see my simulation is integrated inside SolidWorks window. Let's go back to fly out. You can use stationary tool option. So in stationary tool option, the part will move and tool will stay in place. Okay, it's not such convenient for mill-turn machines, but it's really useful for milling machine. So I will disable the stationary tool. You can enable the toolpath view, show the toolpath following the tool, enable or disable solid verification, and a lot of different options. And in additional, you can go to the advanced options, okay, and see other operations. Here we have like kind of styles, VMs, and you can use a default style, you can switch to SolidWorks style, okay, and you can switch to the 3D simulation style without a fixture. Turning part we already seen, and heavy part style, what is allow you to use big components and big parts in more faster mode. And of course you can add a new term or edit the previous one. I believe we have a lot of information on the web done by a US team with explanation how to add them and how to edit it. So I will not go there, but it's give you the control of all environment what you have here. Okay. Now let's back to the presentation. Okay. Of course, Multi-channels machines are major target for the channel synchronization and SolidCAM simulation in multi-channel mode. This powerful engine helps the user to detect conflicts, analyze workflow, reduce cycle time by combining operations in single process. In this presentation, I will not go to these complex tasks because the target was to show how you can use it in simple machines, what is 80% of machines on the market. But again, I want to talk about it and to see what we can do with multi-channel simulation in mill time and channel synchronization. So first, you can automatically control master-slave statement. So if you have axis what can be controlled as slave or can control other axis as master, we detect this case automatically and provide to the customer decision if it's possible to select the master axis for this particular operation combination. We detected impossible by the machine kinematic operation combinations. The easiest one is if you want to combine on single table milling and turning operation together. It's impossible kinematically. So we will block it from you and show you the collision. So these two operations have a conflict in the spin ratio. So we cannot execute them together in same label. Of course, it will provide you automatic solution for axis superimposition cases, pattern selection, and all cases what you can meet in advanced mill turn. We will not go to the machine simulation or G-code without solving these problems, what we call clashes. In multi-channel machines, the SolidCAM simulation will be used for first verifying the work process before you will run the machine simulation and load all the tools and part to the machine simulation. And of course, the material removal is much more precise in new simulation. So let's see an example. In the following part, we are running a NTX dual channel machine, and let's see how it looks like in the new simulation. First, when I right click on setup, I can find the SolidCAM simulator in multi-channel mode. So when I open it, you will see the first workpiece is loaded and the second on the second screen. In second workpiece, I can see all tools are mounted together. So if I have any collision between neighbor tool to the workpiece or fixture, I will see it. In the first screen, we are running B-axis here. You see now only the B-axis. So let's see how the simulation looks like. I will rotate the component a little because in real life we started in the lower position, and let's see the simulation. Of course, you can see here in the taskbar the two channels are executed. Let's run it. So now I see both channels are executed simultaneously. Both tables are busy by work and by working each one on separate table. Now this table is in the idle process, is waiting for something, but this table is work in balance mode on the part. Once I will finish, we will switch to work to the second table. So you see the real execution order of operations, how we design it in channel synchronization on this kind of simulation. Of course, once you finish the verification and you see your toolpath is perfect, you can go and open machine simulation to finalize the verification process. But running this simulation is much more faster and allow you to use all tools what you have in Solid Verify simulation and turning simulation to verify the toolpath and material removal. Okay, let's go back to presentation. So I was really glad to present this new functionality to all of you, and I hope everybody will try it once and play with it. It's give a lot of effort for not only for multi-channel machines, also for single channel, simple 3-axis, dual table 3-axis machine, 5-axis machines. And thank you for watching.